Hello, relativity friends. We've been doing some Christoffel the Symbol extravaganzas. I got one more here. What is the actual the physical significance of this thing? Okay, we've the last couple of days we looked at what is its geometric significance. Now let's start thinking about what is the physical significance. Okay, this video is based on the book General Relativity: An Intuitive Approach by this, and I'll leave a link to the book in the description. Okay, in Newtonian physics, a gravitational field can be viewed as this beautiful picture off of Wikipedia. So the blue lines are the gravitational field lines, and you see the Earth is a sink, and here's the moon. That's a baby sink. This is not to scale, obviously. Uh, and the red contour lines is the gravitational potential lines. Okay. So we got vector field lines and we got scalar gravitational potential lines. Okay. The gravitation of the vector, the field, it can be written like this: G is equal to negative del phi. So the G is a gradient of phi, the gravitational potential. All right, let's write that out fully, what it would mean. It would look like this. So it would be the partial derivative of this potential with respect to the coordinates times the basis vectors. All right. Now, let's compare directly underneath that what a Christoffel symbol looks like. Here's a Christoffel symbol written out in tensor format. Even though it's not a tensor, this is a tensor format. Okay. So we have the partial derivative of the metric tensor with respect to a coordinate. Now compare that to this. So the metric tensor is acting like a gravitational potential, right? So this is how you would determine the field in Newtonian physics. So this is the equivalent of how you would determine or express the gravitational field in general relativity. So this is the generalized form of this. And according to the literature, it says that if you do what's called the weak field limit, so you're a test mass moving slowly toward a not very large gravitational field like Earth, this will reduce to this. So this could be the generalized form of that. I have not done that calculation because I don't quite understand it yet. If I do understand enough, I can explain it. I'll show it. Otherwise, I just think it's really cool that these things do have some the physical significance, although it's not directly proportional as this is. It still is analogous. That's the way I would say it. Okay? Wasn't that fun? I'll see you later.